Thank you for watching today's video. Today we're looking at the revision for area and volume. Now, question number 1. This diagram here shows a regular hexagon with sides 6 cm. Hexagon meaning it will have 6 sides, right, and it goes to 6, and it's regular meaning that all the different sides over here has the same measurement. So this is all going to be 6 cm, 6 cm. And not only that, we can cut them in equally into 6 congruent triangles, right? If you were to know that, then the total angle would be 360. If I divide by 6, I'm able to get one angle over here to be 60 degrees. Okay, and not only that, this is actually an isosceles triangle because something like a radius, the different length across is all equal in length, and that makes it further that this one is also a 60 degrees. So you will actually get an equilateral triangle. Therefore, this length over here is also 6 cm. So this length is 6 cm. Okay, for those, then the question says that show that the area of the hexagon correct to one decimal place is 93.5 cm square. When they say show is equivalent to asking you to find the area of the whole hexagon, and just that you must make sure that the answer you get is 93.5. So now how am I going to find the area of the hexagon? This hexagon can be cut into 6 equal triangles, 6 congruent triangles. So if I can find the area of one triangle, then I'll be able to multiply by 6 the area of whole hexagon. For the students in Set 3, you can use the formula area of triangle equals to half AB sine C, because this length over here is 6, the other length is also 6, right? But for students who are in Set 2 and you have not learned the formula on half area of triangle to be half AB sine C, what you can do, don't worry, you can find the length over here, this perpendicular height, OM first. Okay, then we take area of the triangle to be half times base times height. So now technically, if you look at this triangle, this OM here is actually a perpendicular height over here. The whole thing is 6. This is like an isosceles or equilateral triangle. When I draw the perpendicular distance over, this one will cut it into 2 parts. So this will be 3 cm. So technically speaking, I have a triangle, a right angle triangle over here, where this is O to M and this is O to C. This is 3 cm, 6 cm, and a right angle triangle. So we can use the Pythagoras theorem to find OM. So using the Pythagoras theorem to find OM will be equals to, since we are looking for the shorter side, so we'll do a subtraction, 6 square minus 3 square. Square root. So square root of 6 square minus 3 square will give you 5.1962 in 3 sig. Okay, so I'm going to just write this number, 5.1962. This part is actually important because you need to use it later, right? So now I can proceed to find the area of the one triangle and the area of the whole hexagon. So area of hexagon will be equals to, there are 6 equivalent triangles, so it's 6 times half times base, our base over here, the green one, this is 6 cm, times the perpendicular height we found, 5.1962, right? And that will give us an area of 93.5316, approximately 93.5 cm, correct to one decimal place. Sure. Right, so this is what they asked us to show. So we found this answer for part A already. Okay, have you gotten the concept? So if so, we are going to move on to the next part of the question. Part 2. This pyramid itself with the hexagonal base has a vertical height 20 cm inside this figure. So what are things that we actually know that can be transferred from the base to the new one over here, new diagram over here? So what we have actually found, number 1, we found the base area over for the hexagon to be 93.5316. So I'm going to just indicate that the base area is 93.5316. That's my base area. Not only that, we also found the perpendicular height, OM, over here. So this is OM, right? This is my OM on my perpendicular height. So this is on the base. So OM is actually down here, which is 5.1962 that we have found. Okay, and now we know the additional information that the height over here is 20. So this height is 20 cm. Okay, what can we see? We can see that there is actually a right angle triangle over here where this is my slant height, x to m. So x to m is now my slant height. Okay, and we have all our base for all the different triangles, the different sides over here to be 6 cm. So this one over here is 6 cm, 6 cm. Okay, all throughout. Okay, so now before we begin to do the questions, let us recall a little bit more of our different formulas. What do we know about pyramid? The volume of pyramid is equals to 1/3 times the base area times height. So anything that's sharp will always have a fraction 1/3 for its volume. Okay, then not only that, we can also know the total surface area. Total surface area is given by, for this pyramid itself, this one is a little bit special. It has a hexagonal base and it's a regular hexagonal base, so they will have a total of 6 identical triangles. Okay, let me try to draw them. Okay, so they will have 6 identical triangles, although mine not very identical, right? Yeah. Okay, but how do I find the total surface area? The total surface area is given by the base area, 93.5316. Okay, plus, so I take the base area. In this case, I'm going to add the area of triangles. Okay, in order to find the area of triangles, we need to know the slant height, which is this one over here. We need to know the slant height and the base, okay, to find the area of the triangle. So in order to find this slant height is actually given by xm. So this is xm, and we know the base over here on this side is 6 cm. Okay, over here, this one is 6 cm. Alright, so these are some information that we can think of and we might need to find also later. Right, now first question, let's answer our question. First question, find the volume of the pyramid. So in order to find the volume of the pyramid, part 1, volume is equals to the formula 1/3 base area times height, and we know the base area is 93.5316. So volume is equals to 1/3 times the base area, 93.5316, times the perpendicular height, which is 20. Okay, then now we're going to work out the answers. The answer is 623.544, rounded it off, 624 cm cube. Okay, 3 SF. Right. Next one, question asks us to calculate the slant height, which we have already identified the slant height to be xn. So the slant height over here, inside this green color portion, this is the slant height. Now we already know that this is 20, this is 5.1962, so we can actually form a right angle triangle. This is 20 and this is 5.1962, a very small length. Then this one will be my slant height, usually denoted by the letter L. So they want slant height mx. So mx is equals to, I'm going to use the Pythagoras theorem. We are looking for the longer side, so it will be addition. So it will be 20 square plus 5.1962 square. Okay, 20 square plus 5.1962 square. Alright, and I got the height of 20.664 cm. In 5 feet first because later we need to use this. So 20.7 cm for the slant height. Next part of the question, they ask us to calculate the cost of painting. What do we need to paint? Painting the pyramid. What do we need to paint for the pyramid? Length, area, or volume? Now let's read the questions a little bit more. Painting the pyramid, if it costs 5 cents to paint an area of 6 cm square. So this is clearly talking about the area. So we are going to find the total surface area for painting the whole pyramid. How do we find the total surface area? We know that the total surface area is given by the base area, which we already have, plus the area of all the triangles. So there are a total of, in this case, there are 6 triangles, so we need to multiply by 6 triangles. But what have we found? What information we found? We found the slant height to be 20.664. Right? So now I know the base, the slant height is 20.664, and the base over here, this part is 6 cm. Okay, so we can find the area of one triangle and we add up the area of the base. Right? So for part 3, to find total surface area, we're going to take the area of the base, 93.5316, plus area of 6 triangles, half time the base is 6 cm over here. This is my base, right? Then the slant height we found is 20.664. Half time base times 20.664. Okay, and we add up this total. I get a total area of 465.48. Round off to 5 feet. Okay, cm squared. Then now the question says the cost is 5 cents an area of 6 cm square, right? So what does that mean? It costs for 6 cm square will cost you 5 cents. I'm going to change the cents to dollars. So 0.05 dollars, which is 5 cents. Okay, then I have 465.48 cm square. We're going to calculate the cost. So I take this divide by 6 times 0.05. Right, which gives me in money $3. Money is 2 DP, 88 cents. Right, so this one will be the answer for our question. Have you gotten the concept? Next question, question number 2. A conical container has a diameter of 10 cm. Now, usually for me, when we find out different formulas for cylinder or cone or whichever, usually we'll use the radius. So in this case, I'll just find out the radius is 5. I'll just draw another one. The radius is 5. Okay, and it has a height of 8 cm, so the height is 8 cm, filled with water to a depth of 4 cm, so the water is 4 cm over here. Okay, but you notice they did not give me the radius, so I just let the radius here be r. Okay, and then we can probably find a relationship to find the radius itself. Now, next part of the question says, show that the volume of the water in a container is so much. So before we begin with doing all the different questions, let me just graphically go through the different formulas that we have. Volume for cone. Okay, anything sharp will have 1/3, right? So it's 1/3 times the base area. In this case, the base area is of the shape of a circle. So it's pi r square times the height. Okay, then curved surface area of cone, the curved surface only, curved surface area of cone is given by pi RL, where L is the slant height. So this one here over here, this portion will be my slant height, or it can be this one, the larger slant height as well. So it depends on the question. Now, since the question wants me to find the volume of water in the container, that means I will need to find my radius, isn't it? So let's try to observe a pattern, something that's from our diagram. What do we actually see? We notice that there is this triangle over here, and there's another triangle over here. Now these two triangles are actually similar triangles. Why is that so? Number one, the angles over here are the same and they share the same angle, so you can see very clearly. Then the third angle definitely will be the same, so you can see very clearly that all these are actually same equal angles, and you have similar triangles. So when we have similar triangles, what can we find? We can find that the ratio, okay, of all the different sides are in equal proportion. So if I were to find the radius, this is my R, right? So radius over small one over the bigger radius, which is 5, will be equals to the ratio of the proportion of the height for the smaller one over the height of the larger one, which is 8. And from here, 8 divided by 2 to give you 4. So 5 divided by 2 will give you R. So therefore, or you can do cross multiplication, right? R will definitely be 2.5 cm. So after we found the radius to be 2.5 cm, we can now happily find the volume. When the question says shows, it actually is equivalent to find the volume. Just that you must make sure the answer is this, 25 pi over 3. So now let's find the volume. Okay, volume of container is given by 1/3 times base area, which is your pi R square, 2.5 square, times the perpendicular height. Height of the whole water is actually, the water itself is only 4. So it's just 4. Okay, now you notice inside here there is this pi over here, right? So there's this one is pi. That means we are going to leave the answer in terms of pi. We are going to calculate every other thing except for pi and leave pi alone. And we should be able to get 25 over 3 pi cm cubed. Okay, and check for calculations, see whether it's correct or not. Now, what do you think they ask us to leave the answer in terms of pi? So exact. Okay, there will probably be a part that we need to use this volume for the next part of the answer. Okay, now next part of the question, find the surface area of the inside of the container that is in contact with water. Where is the portion that is in contact with the water? Well, this is the portion, this is the curved portion that is in contact with water, right? So actually what do we want? We want the curved surface area of the portion that's in contact with water. And curved surface area is given by pi RL. Then one question, is this portion over here in contact with the container? This is the water itself, right? The surface of the water. If you are just looking at the surface area of water, but is this portion in contact? Is it touching the container? No, right? It's not touching a container. So do we need to add the area for this circle? No, we do not add the area for this circle. So we do not want this portion over here to be added. So we only really want the curved surface area. So if we want the curved surface area, formula is given by pi RL. That means I'll need to find the slant height, L, over here. And we have clearly our radius is now, we found the radius to be 2.5 cm. So I'm going to just replace this with 2.5 cm. And then we can use Pythagoras theorem to find the slant height, L. Okay, so using the right angle triangle, this is our slant height. The height here is 4, this is 2.5 cm. So slant height will be equals to, we are looking for the hypotenuse, so it's an addition. Okay, square root 4 square plus 2.5 square, and that gives me 4.7169. 7 will do. Okay, and now I'm going to use the formula to find the surface area that's in contact with water. Pi RL. The radius of the water 2.5 cm, the L 4.717. Okay, they never asked me to leave the answer in terms of pi, so it should be 3 feet first. That's pi. And I got the answer 37.047, rounding off 37.0 cm squared. Okay, have you gotten your answer? Next part of the question, part B, the water in the cone. How much is the water in the cone? The water in the cone is poured into a test tube. So how much is this water in the cone? We found the volume to be, or we have shown that it's going to be 25 over 3 pi. So even if you do not know how to do part A to find the volume, you can still use the answer over here, the one that's given over 25 over 3 pi to help you find the answer. Okay, so this is actually talking, the water is actually talking about the volume. So we know that the volume is equal to this. And this test tube is made up by joining together a cylinder with diameter 3. As usual, we usually use radius. So I'll immediately calculate. The radius will be 1.5, right? And a hemisphere. So if I have a hemisphere over here, hemisphere will get the same radius, also 1.5, and the height over here, okay, I just like imagine you turn the radius a little bit. This radius is also 1.5 cm. Okay, so I didn't know the height over here is 1.5 cm, right? Now the question is ask us to calculate the height of the water in the test tube. So I need to find the height of the water in the test tube, which means I need to find the whole height. This whole height is the height of the water in the test tube. Okay, but I do not know the height of this part of the cylinder. Okay, I shall let this be H. Is that okay? Okay, I shall let this H be the water of this part of the cylinder that's filled with water. Okay, so I'm letting H be the height of water that filled up the cylinder. Okay, then now what we're going to do, we're going to find the volume. We are only given the volume, the information on volume, so we know that the volume of the whole figure is given by volume of cylinder. How do you spell cylinder? Plus the volume of the hemisphere. Correct? So let's revise a little bit on what are the different formulas for cylinder. So if you're going to look at cylinder, volume of cylinder is given by the base area times height. The base area is the shape of a circle, so it's pi r squared times the height. Volume of a hemisphere has a half, is half of a sphere, right? So formula for volume of sphere is 4 over 3 pi r cubed. Now this one over here can be found on your formula sheet, the 4 over 3 pi r cubed for a sphere, but this one is not given in the formula sheet. So this one for volume cylinder, you have to memorize it a little bit. Okay, so now we know this is the formula already. Let's plug in our information. We know that the volume of the water is given to be 25 over 3 pi. And the volume of a cylinder is base area pi r squared. The radius is, 1.5 is the radius, times the height h, which I need to find and do not know, plus the volume of hemisphere, so half times 4 over 3 pi r cubed, which is 1.5 whole thing cubed. Now you'll notice that there's something over here that is actually a common factor throughout. Pi. All of them have a unit, pi units. So what we can do to simplify the whole equation to make it easier for the calculations, we can drop away the pi and we'll be left with 25 over 3. This one is 1.5 squared. That gives me, since it's decimal, I work in fraction. improper fraction for algebra. So 9/4h plus half times 4/3. Leave out the pi, 1.5 whole thing to the power of 3, 1.5 cubed. I'm left with 9/4. Okay, no more h, no pi. Okay, and now how can we solve this equation? We're going to subtract away 9/4. So this will be 25/3 minus away 9/4. And we get 73/12. So this is 73/12. This is 9/4h. I only want to get h, so I'm going to divide by 9/4 straight away. So I'm going to divide by 9/4 and get my answer to be, it's going to be a decimal or a fraction. Now we're talking about height. So height is a measurement, appropriate measurement. So it's okay to leave your answer in decimal places or 3-sig rather more convenient rather than a fraction itself. So I should leave this answer as a decimal place. Then I round it off the h later. Okay, but this is only the height of the water in the cylinder. I want to find the height of the whole water, the water in the whole test tube, which is actually h plus 1.5. So I need to do the last step. Height of water will be equals to 2.7037 plus 1.5. Then I'll round off this answer to 4.2037 into 4.20 cm. Okay, have you gotten the concept? Okay, last question for this part of the lesson. Okay, inside this diagram, you have a hemisphere of radius 9 cm and a cone is hollowed out of the top of the hemisphere. Now, for this kind of question, you have to be very careful. For questions when you hollow out, you can cut out new things, right? Normally, students will just take, the volume of the hemisphere minus the volume of the cone. That gives you the remaining. Well, that is true for volume, but it's not necessarily true for surface area. If the question asks you to find the total surface area, you cannot just say take the volume of the hemisphere minus the volume of the cone. That is not true, because when I cut out certain things, right, I create additional surfaces. Well, some surface really become lesser, like for example the hollow circle over here. Right, this one here, the area is being cut out, so this one is going out, right? I'm going to subtract this area of the circle. But when I carved out this hollow cone itself, I'm creating new surfaces. This curved surface area here is being added, is being newly created. So for this portion over here, this cone for the surface area, I need to add this cone, add the surface area of this cone. But for this portion over here in my circle, I need to subtract this circle because I cut out that actual hole, but I'm creating a surface for the cone as well. Okay, so later if they ask you on questions on surface area, you have to be very careful, right? Do not just minus off directly. Okay, let's read the question a bit further. A cone has a radius of 3 cm and a height of 4 cm. So now let's recall our formulas first. What are the formulas for volume of sphere? Volume for sphere, in this case, is hemisphere. Okay, hemisphere, or volume for the sphere. Hemisphere will be half times 4/3 pi r cubed, right? And what about volume of cone? Volume of cone is given by 1/3 base area, which is your pi r squared times h. These two formulas are all given in your formula sheet, so do use them. Not both of them, sorry. This one for sphere only, right? Then next part, I also want to know the surface area, correct? So curved surface area, I will write CSA for short, for hemisphere, not hemisphere, but for a sphere, is given by 4 pi r squared. Okay, and the curved surface area for a cone is given by pi RL, where you know L is the slant height. So I probably need to find the slant height also. So this one is my L, the slant height. Okay, so question, let's take a look at our question. Number 1, part A, find the slant height of the cone. Okay, so we already know that this is a right angled triangle over here. You have 3, you have 4. So we're going to find the 3, 4, and it's a right angle triangle, the slant height. So we're going to use Pythagoras theorem, square root, hypotenuse, so we're going to add it. 4 square plus 3 square, and you will find that this answer is actually 5 cm. Okay, so we already know this answer. I'm going to add it in. Find the curved surface area of the cone. The curved surface area of the cone, part B, that will be given by the formula pi RL. So surface area, curved surface area is given by pi RL. Our radius for the cone is 3 cm. Slant height is 5. So I got this answer to be 47.124, and rounding off 47.1 cm for 3 sig fig. Okay, for part B of my answer. Find the curved surface area. Find the surface area of the solid. So now to find the surface of the area of this solid, we need to find it part by part. Okay, so let's look at the first part that we can think of. The very first part, usually I go from top to bottom, I'll top down. The top part here, there is this I'll call it the donut. This actually is the whole circle, right? Minus away the smaller circle, the one in yellow, right? So let's take a look from the top to the bottom first. So if I want to find the total surface area, this portion, this donut here, I'll call it number 1, area of the donut. Okay, so I'm going to do part C to find the total surface area. The first shape is this one that looks like a donut over here. Okay, our radius for the hemisphere is 9 cm and the cone is 3 cm. So the first one, the bigger circle, the radius is 9 cm and the radius for the smaller circle is 3 cm. So in order to find this donut, the area of the donut, I'll take the area of the big circle minus the area of the smaller circle. Okay, I'll subtract them off. So this part, yes, it cut out, there's a hole there, so I need to subtract. So area equals to pi r square, the bigger circle, minus the smaller circle, area pi 3 square. And that gives me 226.19. Okay, so that's the first part. What about the second portion? Now, after I cut it out, let's look inside, right? This portion over here, the curved surface area, portion number 2 is being added, newly created. So I need to find number 2. I need to add in curved surface area of the cone. So this part here, the curved surface area cone, which we have already found it just now. So this is my number 2. The area over here is given to be 47.124 cm squared. Okay. Then last but not least, I need to find the surface area over here. This is the whole surface for my hemisphere. Okay, so we know that the surface area, curved surface area for a full sphere is 4 pi r squared. For hemisphere, it will be half times 4 pi r squared. So now I'm going to find the curved surface area over here, this portion. Oops, didn't look like a sphere. Okay, this portion over here is given by the formula hemisphere. So I need a half times 4 pi r squared. What's the radius for the whole hemisphere? Oh, 9 cm. So 9 squared. Okay. And that will give me 508.94 in 5 sig feet. Then now I'm going to calculate my total surface area. So the total surface area will be to add all this together, and I get a total of, let me do a calculation. 782.254, rounding off 782 cm square. Have you gotten the concept? Okay, next part of the question, find the volume of the solid. So volume of a solid is easier because you are used to it. I'm taking the volume. Okay, the volume will be equals to the volume of hemisphere minus away the volume for the cone. Volume of hemisphere has a half, and formula is given by 4/3 pi r cubed. The radius for the hemisphere, 9 cubed. Minus the volume for the cone, 1/3 pi r square. Base area pi r square, the radius for the cone is 3, times the height of the cone. What was the height of cone? Is it 4? Yes, the height of cone is 4. So times the perpendicular height, 4. Okay, and then we can leave this happily in 5 sig feet. And I get the number 573.03, rounding off to 3 sig feet, 573 cm cubed. Okay, have you gotten the answer? Now with that, we come to the end of this part for today's lesson. We'll see you again for the next lesson. Goodbye.